Lesson 9.4 is analyzing the derivative graph level 1. Number 1 says the graph of f prime, which is the derivative of our normal function f, is shown below. Determine the values of x, if any, at which the function f has a critical value on the interval -9 to 9. So we talked about how this just tells you the x values that your function goes from. It tells you they're open circles instead of closed. But what we're thinking here is these are all slopes at specific x values. So if I had my normal graph, which this is actually the answer on Delta Math once you submit, so you'll see it. But I wanted to have this on here just so you could see what's happening. So we've got to train our brain to work backwards or think backwards. Right here, when x is -9, think about what kind of slope this line has. Right here. I shouldn't even say slope on this. Think what y value is at -9 is -2. So on our normal graph, there should be a negative slope, -2 slope when x is -9. Then as it gets closer to x is -8, this has a y value of 0, saying our slope is 0. We call those critical values. So I made a little note here. It's where your slope graph, your derivative graph, will equal 0, the y value of it. So that would be here, and here, and here, and here, and here. But all along this is saying the slope is negative, the slope is negative, the slope is negative, and then the slope is 0. Now we're up in positive y values because we're above the x-axis, so all these slopes are positive on our normal graph. Even though we're decreasing, our slopes are still positive, just here they're getting very steep. At -4, it's the steepest it ever is, and then the slope gets more gradual to where it would be 0. So let's just kind of take that over here and show you what's happening. So when x is -9, see how this slope is negative? It looks like the slope of the tangent line would be decreasing. Then at -8, it flattens out so that it has a horizontal tangent line. And then we said at x is -4, it gets really steep. So that's before you come to a little hill or valley, and then it starts to get less steep to where it flattens out, and there's a 0 slope. We said at -3. That's what that's doing. But anyways, we're going to say that x values of -8, -3, 1, 4, and 8 are our critical values. Okay, go ahead and turn it to the next page. Number 2 says the graph of f prime, the derivative, is shown below. Determine all intervals on which f is increasing on the closed interval. So to think if these are the slopes, the specific slopes of 1/2 or 2 or 3 or -1/2, that graphs the slopes as a y value. And so when we want to know where it's increasing, that's where there's positive y values. And so I don't know if you want to put positive y values up here, but I made these little notes for you. So when the regular graph is increasing, that means on the derivative graph, you'll have positive y values. When you want to know when the regular graph was decreasing, you'll have negative y values. And so we're looking for where is our derivative, our slope above the x-axis. It would be to there. Then the slope becomes negative. Then it would be positive for all of this until it becomes 0 again. These are all negative slopes because they're down here in negative y's. So we would say from -9 to -7, and then from -3 to 1. And here is that graph to show you that our slopes are increasing. So at each x value, it's taking the slope of the tangent line. And at -7, that's where we had that for 0. Then we had negative slope until -3, then we increased until 1, and then we have negative slope. We came to 0 slope again at 5, but we're still negative slope. And number 3, the graph of f prime shown below. Determine the values of x, if any, at which the function f has a relative extrema on the interval. So relative extrema can be a min or a max. They want all of them. And so we're trying to figure out when f prime changes sign. So that means it cuts through the x-axis, or it's going to be the x-intercepts. But it must cross through x-axis, not bounce. Okay, so like right here at -7, that's going to be a min or max because I'm going from I'm looking at this slope. I'm going from positive slopes because I have positive y values to 0, and then I have negative slopes. And so something that has positive would go like this, and then turning to negative would go like this. That creates at -7 a relative max. And you can see that right here on the regular graph. And then at -3, I'm going to have where I go from negative slopes, so something that's decreasing, to then positive slopes, something that's increasing, and that creates a relative min, which you can see right here. And then at 2, see how it crosses through. And at 6, it's not going to be because this is still saying there's negative slopes. And this is where that little kind of slide deal happens. If I get a slope of 0, but it's still going to be decreasing this whole time. And so I can only say at x is -7, -3, and at 2. And then the last one, this is just more specific than number 3. It says determine the values of x where it has a relative minimum. And so that kind of goes back to what I was showing you here. Minimum, we need to go from negative to positive y values. And then a maximum needs to go from positive to negative y values. And so I want to go from, because I want to go decreasing to increasing, decreasing to increasing. And so right here, I'm going from negative slopes to positive slopes. So that would be one of them. I'm going from negative slopes to positive slopes. And then here, I'm going from positive y values to negative y values. So that's going from increasing slope to decreasing. That creates a max. We don't want that. And then right here, I go from negative slopes back to negative slopes. So that's just one of those decreasing, flatten out, decreasing. And then here at 8, I go from negative y values to positive. So that would be another decreasing to increasing, creating a minimum. So that would be at just -8 and 8. And you can see here how that graph matched what I said of we're going decreasing to increasing slope. And then we still decrease, decrease. And then here at 8, we would start to increase a little bit more, so that's a minimum.